Hey guys, welcome to another Algebra 2B video. Today we are talking lesson 12.2, series and summation notation. What is a series? Well, if you remember in 12.1 we talked about sequences. Sequences were patterns of numbers where you have these elements and they just go up, go down. Sometimes you're multiplying to get the next number, sometimes you're adding to get the next number, what have you. A series is a sum of the terms in a sequence. So if you take the numbers in a sequence and add them up, you get a series. We learned how to find the nth term of a sequence in lesson 12.1. We are often very interested in finding the sum of a certain number of terms in a series, and that's where we get, I should say the sum of a certain number of terms in a sequence, and that's where we get a series. So here's some examples here of what I'm talking about. If we have a sequence that's just the basic numbers 1, 2, 3, 4, the corresponding series would be 1 plus 2 plus 3 plus 4. If we had even numbers 2, 4, 6, 8, then the series would be 2 plus 4 plus 6 plus 8, and so on. If we had some fractions, 1 half, 1/3, 1/4, 1/5, 1/6, the sum would be 1 half plus 1/3 plus 1/4, and so on. Because many sequences are infinite and they do not have defined sums, we often need to be able to find partial sums. A partial sum is indicated by the capital letter S sub n. Remember, we used A sub n for a sequence. We're going to use S for a series. It's the sum of a specific number of terms in the sequence. So for the even numbers, S1 is 2, S sub 2 is 2 plus 4, 6, S3 is 2 plus 4 plus 6 or 12, and so on. So you're looking for the sum of the certain number of terms. What we can use is what we call summation notation. A series can be represented using summation notation, which is the Greek letter sigma, which is this really funky looking E. It's denoted by the sum of a sequence defined by a rule as shown. So we have this guy here. On the bottom, we usually use K for sums in your calculator when you use them, and I will show you how. I'll show you how in class. We usually use X, but it's the same idea. We have K equals 1 on the bottom. That's your first value. The number on the top is the last value. So this is, we're going to add this terms from 1 to 5, and this is our rule, 2K. That's the explicit formula for the sequence. Remember, we found these explicit formulas in lesson 12.1. So basically I would plug in 1 times 2, 2 times 2, 3 times 2, 4 times 2, 5 times 2, and add those all up, and that would be my sum. So to write a series in summation notation, this is what you do. So if I have this, 3 plus 6 plus 9 plus 12 plus 15, those are multiples of 3, right? We're multiplying by 3. So we have A of k, or A sub k is 3k. That's your explicit formula, right? So the first term, 1 times 3, 2 times 3, 3 times 3, and so on. To write that in summation notation, I'm going to say k from 1 to 5, and my formula is 3k. If I have these guys here, fractions, and I'm adding and subtracting, all right, so I got 1 half minus 1/4 plus 1/8 minus 1/16. The rule is going to be basically 1 half to the k power. But since I'm alternating plus or minuses, if you look over here, if you start with a positive, you're going to use -1 to the k plus 1 power. And if you start with a negative, you're going to use -1 to the k power. And that will allow us to alternate these plus or minuses. And we've got 1, 2, 3, 4, 5, 6 terms here, so we're going to go k from 1 to 6, -1, k plus 1 times 1 half to the k. So let's go over to the note sheet here. And this is a lot of what we just talked about. A series is the sum of the terms of a sequence. And then we have this summation notation is used to represent a series. The Greek letter sigma denotes the sum. On the bottom, you've got your first value, your first term. On the top is the last value. And then the function here is the sequence rule. So to evaluate a series, you expand it by writing the terms in the sequence up to the nth term, and then you add them together to find the sum. So if I'm given a rule, like this guy here, k 1 to 5 of k squared plus 1. So as I kind of articulated in the example, I'm going to find k of 1, k of 2, k of 3, k of 4, k of 5. So 1 squared plus 1, 2 squared plus 1, 3 squared plus 1, 4 squared plus 1, 5 squared plus 1. Evaluate each of those, I'm going to add them all up, and get 60. And then for this one here, from 2 to 4, for this rule here, negative 2 times 3 to the k. Whoops. So we're going to get negative 2 times 3 squared plus negative 2 times 3 cubed plus negative 2 times 3 to the 4th. Those three terms, add them up, and you end up getting negative 234. So let's take a look at these. Let's work some out together. So we have here the sum from 2 to 5 of 4k minus 1. So this is, here it's k equals 2, then we got k equals 3, here's k equals 4, and here's k equals 5. So let's work it out. 4 times 2 is 8, 8 minus 1 is 7. 4 times 3 is 12, minus 1 is 11. 16, 4 times 4 minus 1, that's 15. And 4 times 20 minus 1 is 19. So I'm going to add all those up. 7 plus 11 plus 15 plus 19, I get 52. Number 2, from k equals 1 to 4 of 1 over k. So this is 1, 2, 3, fourth term. We're just going to add those up. That's going to be 1 plus 1/2 plus 1/3 plus 1/4. Now when you're adding fractions, you got to have that common denominator, or you've got to be able to use your calculator. You can use the alpha y equals, remember that, on the graphic calculator, the alpha and then the y equals key, and that will bring up your fraction menu, and you'll be able to add them up that way. You're going to find this guy here, numerator, denominator, and you can type them all out that way. That's what I'm doing now. That's why it sounds like I'm stalling, because this takes some time. But I'm adding them up. 1/2 plus 1/3 plus 1/4 plus 1, which was my first guy. And I get 25 twelfths. Or 12 and 1/4. Or 12 and 1/12, I should say. No. 25 twelfths is 2 and 1/12. All right, fractions. Sum from 1 to 4 of k equals 5 to the k minus 1. So this is the first term, the second term, the third term, and the fourth term. So let's see. 5 to the 1 minus 1. 1 minus 1 is 0, so 5 to the 0 is 1. 2 minus 1, that would be 5 to the first, 5. 3 minus 1 is 2. 5 squared, that's 25. 5 cubed, so that's what 4 minus 1 is, 3. That'd be 125. So let's see, that'd be 1 plus 5 plus 25 plus 125, giving us 156. The sum from 1 to 3 of 2 to the k plus 1, so that would be 2 to the first plus 1 plus 2 squared plus 1 plus 2 cubed plus 1. So that is, let's see, 2 plus 1, that's 3. 2 squared, 4 plus 1 is 5. And 2 cubed is 8 plus 1 is 9. So 3 plus 5 plus 9 gives us 17. From 3 to 5 for 2k squared minus 1. So that would be 2 times 3 squared minus 1 plus 2 times 4 squared minus 1 plus 2 times 5 squared minus 1. You're just going to replace k with the value of the term. So let's see, 3 squared is 9, times 2 is 18, minus 1 gives us 17. 4 squared is 16, times 2 is 32, minus 1, which is 31. 5 squared is 25, times 2 is 50, minus 1 is 49. So add them all up, I get 17 plus 31 plus 49, which is 97. There it is. So it's a little bit of work, but you can write them all out and you should be able to do it. You could also do this on your calculator, and I will show you how in class, but I could talk you through it right now. If you go to the math menu and you go over to number on your graphic calculator. Oh no, wait, I'm sorry, it's the math. Just go to the math menu and option 10 under the math menu. So if you press math and then go to option number 10, I believe it actually looks like this, 0, dot, dot, and it's summation. I even have the sigma there with a parenthesis. Use that on your graphic calculator and it'll do all the heavy lifting for you. It's pretty easy stuff. All right, so there are some special formulas. Let's see if they talk about them in the textbook. Here's example number 2. Kind of does what we just did. So there's some more examples for you about what we just did. You've got to be careful. Series often has a first value of 1, but if it doesn't, like example A where we start at 3, you got to remember you're going to start at 3, not at 1. So now there's a couple different types of series that have special formulas. First is what we call a constant series. In a constant series, you're just taking the same number and you're adding it over and over and over again. It's almost like the equivalent of a square, but we're adding instead of multiplying. So we get k from 1 to 5 of 3. That's just going to be 3 plus 3 plus 3 plus 3 plus 3, or 5 times 3, 15. So the formula is just going to be n times c, where c is your constant. In a linear series, what we call a counting series, is just basically you've got sum from 1 to 10 of k, where we just go 1 plus 2 plus 3 and so on. If you work it all out, you end up getting, if you kind of work it out and move some numbers around here, you notice we're just getting 11 5 times. So what we end up with is this. Notice that 5 is half the number of terms and 11 is the sum of the first and the last term. So this creates a formula called n times n plus 1 over 2. And then there's also a quadratic formula, which is this guy here. They don't really show you how to derive it, but if you have k squared, it's going to be n times n plus 1 times 2n minus 1 divided by 6. Not something you really need to commit to memory. It's also here in your notes. How do we evaluate this? Well, here we have the sum from 5 to 12 of 9. So we start at 5, and we're going to go to 9, or going to go to 12. So you've got to count the first term, and you've got to count the last term. So here, n is actually 8. There are 8 values from 5 to 12. So we're going to use 8 times 9. It's going to give us 72. Here we have from the sum from 1 to 18 of k. So k is this linear formula. So we're just going to do n times n plus 1 over 2. So 18 times 18 plus 1 divided by 2. That'd be 171. And then we have a squared from 1 to 15 of k squared. We'll do 15 times 15 plus 1 times 2 times 15 plus 1 divided by 6. Do the math, you get 1240. So let's see. All right, so the very first one is another quadratic. So basically what I'm going to do is, I've got from 1 to 9. So I'm going to say, all right, 9 times 9 plus 1 times 2 times 9 minus 1, all divided by 6. So let's see, that's going to be 9 times 10 times 17 divided by 6. 9 times 10 times 17 is 1,530 divided by 6 is 255. Sum from 1 to 12 of 6. So this is just going to be 12 times 6. 12 times 6 is 72. Linear from 1 to 10 for k. So this is going to be 10 times 10 plus 1 divided by 2. So 10 times 11 is 110 divided by 2 is 55. They kind of did all that stuff for us. All right, you know what? That's cool. We're gonna. You would think I've never taught this lesson before, but let's go back and let's write it out the way they want. All right, so the rule here, n is 9. So we're going to get this, like I said, 9 times 9 plus 1 times 2, 9 plus 1. Oh, is it plus 1? Yes, it is plus 1. Oh, so I was going to do it wrong. Hey, it's a good thing. I made a mistake. Look at that. Mistakes are good. We're going to get 9 times 10 times 19 divided by 6. 9 times 10 times 19 divided by 6 gives us 285. Here, n is 12, so we're just going to have 12 times 6. Like I said, that's 72. Here, n is 10. So we're going to get 10 times 10 plus 1 divided by 2. It's like I said, 110 divided by 2, which is 55. And this, in case you were wondering at home, was 1,710 divided by 6. All right, so I also included some notes here on basically understanding what's going on here. Don't worry about this page in case you need a little bit of extra help, but basically this is a nice explanation again of what's going on with the summation notation. This is the first, this is the last, this is the formula you use. I think we've gone over it quite a bit, so we don't really need to do anything more with that. And I don't think there's anything else in the textbook except some more examples of how to figure these guys out. And a problem-solving application. You will probably see some story problems at some point. Ricky's building a card house similar to the one shown. He wants the house to have as many stories as possible. With a deck of 52 cards, how many stories will he have? All right, so the answer will be in the number of stories or rows in the house of cards. He's got 52 cards to play around with, so he wants as many as possible. So it may help to do a little bit of a drawing here. The first row has only got 2 cards in it. Second row has 5 cards. Third row will have 8 cards. The fourth row would have 11. So what we're working out here is we got to work out the explicit formula. We're adding 3 every time. Common difference is 3. And we start out with 2. So they end up with this explicit formula. 3k minus 1. Because basically 2 times 3 minus 1, 2 times 2 minus 1, and 2 times 3 minus 1, 2 times 4 minus 1. So If he does 4 rows, add these up, you get 26 cards. We're about halfway there. Fifth row, it's going to be 3 times 5 minus 1. We're going to add to that. That's going to be 40. 6 rows, he's going to need 57 cards. So he can't do 6 because he'll run out of cards before he can. So the most he can do is 5 rows. So 5 stories. That's it. Your homework is going to be in your Schoology page, and if you learned anything today, smash that like button for me, and I will see you in the next one.